Hello, everyone. Tonight, I think I'm going to try and do something a little bit more technical, something a little bit different than I've posted before. Lean in a little bit more on my experience as a software architect and just kind of walk through the high level architecture patterns that I've seen in the wild and add some suggestions or some recommendations around where AI fits in well and potentially where AI probably is going to cause some issues. So indirectly, this will probably be a general overview of different solution architectures. So bear with me for those who aren't technical. I will try to keep this as business focused as possible to show where things can be interjected and add value to help you and your development teams, business users understand where it makes sense to use AI and where it potentially causes more harm than good. So the main and the simplest project solution design architecture that usually gets created when you're creating like an MVP or a proof of concept is a monolith. So a monolith is essentially what it sounds like. It's one giant code base. It's got everything put together. It's a grab bag of what a standard looks like. In other words, there isn't really a standard. It's just everything's all in one solution, one project, and it's all together. You make changes in one place and it's referenced in a bunch of other places, and it makes for very efficient development cycles in the beginning because you can reference things in multiple places and change lots of things. It looks like lots of stuff can happen really fast. The drawback of that, obviously, is once you solidify it, you've still got all the integration everywhere. So if you change one thing somewhere, it can affect things in other places. So where AI is useful for a solution like that would be in your initial scaffolding, because you can benefit from teasing in more sustainable architecture patterns without actually spending the time on them. AI can generate that scaffolding for you and lean towards one of the more extensible and maintainable architectures like Onion or Clean or just a basic N tier even. So a lot of solutions with the advances we have in like Copilot and just templating, because you can go on GitHub and pull down a solution that has like a third of what you need. A lot of those solutions start off with one of the other architectures. This is really your like greenfield ground zero. I need something today. Let me put it together as fast as possible, cut every corner possible to put it together. So obviously with an architecture like that, one big monolith, you've got to think really fast if it takes off. If it doesn't take off, you wasted the minimum amount of time as possible, which sounds really good, except you really want to be building for value and building for success. So if you build it as cheaply and as quickly as possible, you're going to have to pay back, the difference in that once the demand is there for it to scale. Because realistically, a monolith that's going to host like a multi-tenanted environment with lots of customers coming in and out, it's just not going to work well. You're going to have to lean very heavily on hardware. You're going to need really strict processes. You're going to need a lot of people to make that thing tick. In the places where I've seen where it has been successfully deployed and used as a solution, the team that supported it was 30 or 40 people for this one solution. It's a big monolith, but it required an extensive software delivery team, extensive QA and regression, manual regression, because the technology wasn't built for automated testing. It was built really fast. So when you go down that path, the one thing you want to keep in mind is if it succeeds, you're going to need to pivot really fast to something that lets you reduce your risk while still being able to bring the value. With that in mind, usually you see an MVP built as a monolith, and then you have some exercise once it's successful to transition to another architecture, a refactoring of sorts. A lot of companies try to stuff in as many features as possible to say, well, here's the value add for the additional spend in development and budget. Well, in reality, they didn't pay as much as they should have up front to build it in a way that would be sustainable in the future. So there's some politics that go on that I've seen in certain organizations, particular clients, even over the past decade. There's always an expectation that development is always immediate, like direct, perpetual value add. Like you pay for it once and it works forever, because that's what the marketing is. But the reality is if you build something too fast and too lean, you eventually run into a problem because it just wasn't built to scale. It was built to solve a problem today, and it wasn't looked at from the 5-year lens in the future of what's it need to do 5 years from now. What questions am I going to have 6 months after it goes live that I need to audit and review? You wouldn't build that into an MVP. You might be smart enough to extend it in the beginning using AI to say, all right, here's all the breadcrumbs I would need to add this in relatively easily later. At the end of the day, you're still fighting a losing battle because that giant solution can only live in one spot. So once you're there and you've got a product that has value, that's like the clock is ticking to convert that to something more useful. Now, various architectures like N-tier ports and adapters, sometimes called hexagon, onion, or clean architecture, you can start teasing that into a monolithic solution in the beginning, but you really have to drive for it with the end in mind. You can't just say, oh, we'll just add this new architecture. That's not how it works. That's like reframing a house after it's been built and you put the siding on. It does not work. So you got to start with the end in mind. And you maybe want to think about your solution or the product that you're building instead of here's our code base. This is our product code. The product is the process, the automation, the value that it can bring to a company. So if that means to be able to continue bringing that value or to expand that value, you have to completely replace the code base with a new code base that meets that value better. That's still a warranted cost. Like you should do that because there's a certain point where that monolith is going to just cap out, and the result is going to be customers that you've had for a while getting frustrated with the system that did work. Now it's slow because it couldn't scale. So you really want to factor that in as like your stage 2 of the rocket, so to speak. You build that basic system, you get off the ground. It's just one big booster, goes right up in the air. And then once you're in the air, you got to think about what are you going to do with the more intricate moves. Once you're in flight, once you're in orbit and you drop the big canisters, how do you keep a stable orbit? The way you do that is a lot different than how you get off the ground. It's much more fine-tuned, much more finesse because you don't have gravity to work with. The same way with when you're getting a new solution off the ground, you can get away with a lot because there's not a lot of eyeballs. Once you've got 1,000 customers, you need a solution that you can easily tweak this one thing and know it won't affect something else. That's where these other architectures come through. Now, in baby steps, you can modularize your monolith. You can put together software layers even. That traditional N-tier architecture isn't really modularizing a monolith, but just as 2 ways to bifurcate from that giant ball of mud you're at now with a monolith, you can break apart by technical function the code base and say, here's everything that accesses a database. Here's everything that accesses all the business logic. Here's the thing that does all the interface. And then if you realize that backing technology, the database you pick to drive everything or the integrations aren't scaling, if you modularize that layer, then you just have to worry about refactoring that layer to switch database providers. In practice, I've only seen that done once in 15 plus years of architecture and software design. So I wouldn't say that's something you should expect to have happen, although it does happen. More often than not, the UI becomes obsolete because of the pace that we're moving with innovating on front-end technologies between Angular, Vue, React, Svelte, Blazor. Like every week, one of them takes the trophy and then the other one takes it the next week. It just keeps moving and moving. So really how you interact, that API layer, if you're going client product or a client interface like JavaScript based or server based, if you're doing something like Blazor server or Blazor pages or Java Enterprise, Spring, if you want to consider when you're putting the thing down, if you know the technology you're picking, you're going to want to pivot from if this thing takes off, decouple yourself as much from it. Put an abstraction there as best you can so that later you can easily drop it off and move on. The maturing model of that, the ports and adapters hexagonal architecture, which is the next level of that, is take a particular integration, like say the database integration or your front-end integration or email integration, and you build a contract, you build a defined set of functions that you want to use, and you define what things come in and out of that within your code base. And then you map those to whatever you're integrating with. So if you're integrating with SendGrid, your core systems don't actually have a reference to SendGrid. They have reference to your abstraction, whether it's a function or a service. And that's your port. And then if you want to swap out SendGrid with something else, or you just want to use Outlook directly for some reason, that adapter, you just need to build something that adheres to that interface, that contract. And then you can plug that into the system. And then you can get really sophisticated if you want to, and you can configure that. And you can turn it on and off per environment. So your lower environments can use OWA, and your higher environment can use SendGrid. And then you can send emails at scale without having to pay for extra accounts in lower environments. So that's one example. Another example would be database provider. Like maybe in lower environments, you use SQLite or something. So you can save money in the beginning and then move to SQL Server managed instance or something for production. Your abstraction would be Entity Framework, but you'd want to put something probably in front of that just to be sure, as long as the Entity Framework maintains its provider base, and I'm very confident that they will, you could treat that as the abstraction. Then it's just provider level. Now, that brings us to the one gotcha with that, which is when you're setting up that when you're building against that, you got to be mindful of what features you use. So like, for example, there's certain things that SQLite can't do that SQL Server can. So if you want to lean on features in SQL Server, you can't build to support both. That's one situation where AI can help because it can do the analysis. It can build the scaffolding for you. It could also highlight the areas that maybe aren't supported automatically and potentially scaffold out some of the code to handle, oh, I'm going to use this function in SQL. It doesn't exist in SQLite in lower environments, so we'll just return a dummy result because we know it's the lower environment, something like that. All that kind of put together, you can use AI to help bridge those gaps of boilerplate all around the solution at that point, and potentially enforce, not just by throwing it in a ChatGPT, right? You got to think a little bit more intelligently about how to guide the model towards the answers. Like you'll want to set out some standards. I want the interfaces this way, these naming conventions, don't reference this, use these namespaces. And then say, all right, write out a draft for this capability. And then from there, it can help you like do some of the mental heavy lifting. Not so that you don't have to, but so you can focus on the parts that add more value as a business. Because the reality is no one wants to pay the 150th time to integrate with Mail Client. So let AI do those things because it's already been done 1,000 times. There's 1,000 different opinions. Just pick one and let it happen. It's not, in terms of moving information from a client all the way into a solution and back out again, as long as the email gets there and it looks good to them, how the sausage is made in the middle, as long as it's maintainable and has good audit and traceability, doesn't matter. The next piece, you go a little bit more inward, is what are you adapting into, that core solution? You speaks more to the focus of domain-driven architecture, clean architecture, onion architecture, where you look at the system a little bit differently once you have that working business model and you realize, oh, there's core parts to this. There's stuff that's technology agnostic. There's a domain of information that when stuff comes in here, other stuff comes out over here. You model that independent of the technology. That should be core to the business. Any business analyst, any programmer, project manager, account manager should be able to articulate not the code way to do it, but how the business process works. And that should mirror that structure. That's really your onion architecture, your domain-driven design. The core is agnostic of the technology. And then you plug in around that the infrastructure and the technology to support it. The benefit of looking at it that way is your domain, while you might have more code and you might write stuff that's more verbose to keep it independent of the infrastructure, that thing will only ever need to change if the language you wrote it in has to change. Meaning that core code, because it won't have any dependencies, could live on for 10, 15, 20 years, right? You could write that domain model and how stuff interacts in C# 1.0 15 years ago. That code's still valid today, as long as you didn't use some crazy fancy feature that got deprecated. At that point, you could have changed database providers, UI, you name it, all along the way. Integrations with Salesforce, integrations with this other tool. As long as the interaction going outside the domain doesn't consider or doesn't have to know about the integration in particular, just that it's doing a behavior. And then that gets mapped to the provider on the outside, that thing can live forever. But that's at the point where you have a sustainable core system you know isn't going to change for the next 5 or 10 years. right? If it changes, you change the behavior, you change the business process, right? All of this goes up in the air, and that's why you actually need a software or solution architect to kind of look at what you have, look at where you want to go, and figure out the most risk adverse way to walk there, to where you can change the system, mutate it to where you need to go, and not have to worry about, oh, I'm changing this provider here, I'm changing this integration, I'm switching vendors. Like, how am I going to seamlessly go from A to B? And then to bring it back to what we hear about a lot in current, maybe not so much current, I feel like it might have, at least for me, it's fallen out of favor to some extent, and I've seen it mentioned less and less in enterprise systems, is microservices. They're made famous by the giant companies, right? The Netflixes, the Amazons, where Amazon deploys every 5 minutes to production, or whatever the metric is. The reality is most businesses aren't large enough to where that's demanded, because what you miss when you see that and you hear, oh yeah, I want to deploy to production every 5 minutes, is the amount of code and orchestration and manual process that still lives even with that automation, documentation, policies, red tape, just to be able to orchestrate hundreds of small services getting deployed and tracked and audited in real time. Because if you're going to be in a compliant environment, like something that uses NIST or something that has to be ISO or PCI compliant, you've got to track all that. So you need this massive paper trail if something goes wrong to be able to point back to and say, oh yeah, no, this was expected, this was just a mistake, this wasn't an attacker, this wasn't whatever. So microservices have this massive overhead that if you can automate to a point, like there's a sweet spot for sure. But once you hit a threshold, it makes sense. But until you're there, it doesn't. Don't go that crazy. There's a middle ground. There's a couple other ways to organize information that are much more, I'll say, value oriented for small, medium-sized businesses, that you can still get the benefits for line of business apps. Obviously, if you have a high throughput situation where certain things need to just run a lot of information and you don't want to have anything in the way, you might stand up microservices that just handle ingestion or things like that, or throughput. Like, that makes sense. So the evolution of a monolith from MVP into one of these other sustainable solutions, rather than look at microservices, I think some of the benefits of what I'll call a domain-bound system, or really a line of business application. There's an example of a company I worked at where their MVP was actually a constellation of access databases. So they had, I don't know, 5 or 6 of these things that each kind of handled a different technical part, because you couldn't stuff it all in an access database. It forced you to shrink, which was good for this use case. They had this internal process where one access database, they load raw client information in, and then they do stuff to it, and it'd produce certain outputs that would then go into the next, which would then be used for something else, which would then produce an output that plus a format of another output from the first database would combine together to produce merge templates for letters, for example, among other things. So in that situation, they took each access database and they built a separate .NET application. I think at the time it was like web forms. Like, this was a long time ago. And they basically replaced each access database sequentially, but they kept the process. So you took the file from the one, you imported into one, you got almost the same file out that went into the access database, and then the work was just in a standardized system. So by the time that migration was done, after a couple of years, they'd reduced like all these errors and issues and lost like all the risk that you get from using a tool like Access that could just crash on you because you're doing something that it's not meant to do, into a custom application designed for it. They got rid of all of those issues. They gained the benefits of auditability and performance from using like an enterprise grade SQL Server and .NET as a backbone. And then from there, they just solidified their process. So that hummed along for years without any issues. Towards the end of it, those 5 or 6 systems, the business, from a, not to any detriment of the software, but just for lack of value generation in the market for what they did, I don't know how else to say it, they ended up getting sold, and they decided to take that 5, 6, 7 distributed system and collapse it into a monolith so that they could better sell it and put a cohesive face on it. Because internally, as a business process, it's fine if you go from system to system, that's specific tasks to workflow. But when we're going to sell a product, you want it to be a cohesive thing. So that's the other thing to consider. If you're doing product development, how you architect it and how you're planning to ship it, that has an effect on what architecture you choose. So if you're going to ship a product, and deploy it and install it on someone's system, then you might choose an architecture for ease of delivery, where you might have to walk a tight line between monolith's hard because it's large and cumbersome at times, but it's easy to ship because it's just one big zip file at the end of the day. Take it and ship it. Now, if you're doing a SaaS platform where someone logs into their tenant and they don't actually deploy to their infrastructure, you own the infrastructure, you can do whatever you want. So one of the things that probably should come to mind when that type of a decision is up for grabs, like whether or not you should pick based on delivery, is really your business model. If you're selling services that are the equivalent of, let me deliver and install a copy of this, and it needs to be isolated and live in an environment that has regulations and you can't touch it directly as the vendor, then you may just have to deal with the overhead of having a monolith. And if you own it and it's your system and they're logging into it, then you can be as flexible as you want. So you can make it more tolerant and whatnot. That's why all these SaaS companies own, here's your web login to our system. And then they'd rather integrate with your login. They'd rather integrate with all these other things. From a business perspective, because you're sticky, right? And then you're more likely to keep using their software, and they can gather analytics and they can figure out what's being used and they can add features around it. But just from a manageability standpoint, if you control your own infrastructure that your product's living on, you can tailor the two to be the most optimal. With that use case, you almost come full circle, right? Because depending on what the business case is, your architecture shifts. It's another reason why you have to have somebody come in and look at what you're trying to do before they actually dictate a solution. You can't just say, oh, everyone's using microservices, we'll just use microservices. Or everybody's doing serverless, we'll just do serverless. Yeah, you have to look at what the 10-year roadmap is going to be for this thing when you build it, so that you don't put yourself into a hole you can't dig out of 5 years from now. Another, what I'll call the most risk-adverse way to develop software that I've seen, is what's called a vertical slice, or some places call them self-contained systems. I think that's probably too vague. But the idea is you take a feature and you basically treat that as an isolated unit within a broader solution. This could look like a monolith, except it's not. It's essentially a giant constellation of tiny monoliths or microservices. But in the grand scheme of things, it's not really a microservice, because you're taking the feature end to end. If you were going to do this in the truest sense, your UI, your business logic, your data access, everything lives within that slice. It's a self-contained unit with defined boundaries on either side. So it's essentially like a really thin version of an MVP with what MVP means, feature complete. And then you just stack them next to each other, and they don't directly interact with each other because that would violate the rule. But then you gain the benefit of, if one feature, something breaks, it doesn't impact any other feature. Now, from that, you can branch into this concept of a microkernel, which you could technically do from any of these. Because at this point, I hope everyone realizes it's a spectrum, and it's not a circle, but it's an oval, in the sense that some of these things connect to other permutations of how you would do this in different ways, and there's shortcuts to get from one solution to another, and there's trade-offs when you make certain decisions. The microkernel is essentially the amount of plumbing you need to be able to sit use case specific logic on top of, that you just repurpose for different things. So you could have that microkernel, which doesn't necessarily mean the same as a core in clean architecture or a domain being built out. It could be just your infrastructure. Like, everything talks to Entity Framework, everything talks to this. It all uses Azure Analytics, all the logging goes there. Put all that in your shared kernel, and then you just interact with a couple of interfaces that basically give you all that usability in all these features. The features just care they're consuming that external interface, and then you're off to the races. So when you're putting together a shared kernel, it's very meta. It's very abstract in the sense of, like, your business user isn't going to necessarily care what goes in it. They're going to care that it surfaces standardized capabilities, that things that they build will all carry forward. So, for example, if you're in your shared kernel, you handle a data access over entity framework, and your plan is to reuse the way you implement that for sorting, paging, filtering tables on screens, then every time you build a table, your business user is going to expect the same level of functionality because you built it once and it gets reused across these features. So when you're looking at the best way to leverage newer tools like AI to help extend these, AI could probably write a feature slice if you just gave it enough context for you. Here's how I want it organized. Here's how, because it's supposed to be as lean as possible and straight to the point. So you could develop all these tiny feature slices in isolation. Your only limit is your context window. And then your ability to essentially validate that it did it correctly and it used it. So if you give it all the external interfaces and say respect all these interfaces and build out a feature that leverages these, it's going to produce pretty decent features. The problem is the size of the feature is going to be really small. You're not going to be able to say, oh, give me a user management as a feature slice. It's going to try. It's going to give you a table. It's going to give you a form. But you're going to iterate over parts of that multiple times just to refine it. Now, it might be that you refine your starting prompt to say, prefer writing code this way and organize stuff like this and use these naming conventions and don't implement X, Y, and Z. And then it'll build 80% of your boilerplate. That's an efficient way to do it. That works great with feature slices. Microkernel, very abstract. You want to give it laser focus. If you're going to have something get templated, you want to say, do all the research on currently how Azure Entra works and build out guard code around possible failures and build an authentication management service. Big complicated class, but relative to the size of the solution, it's small. AI can do that. You got to vet it because you own that code after AI writes it. So you have to understand 100% of what it wrote before you say, as if it's the code you wrote, because it's just a tool. You can't point to AI and say, oh, AI did this. It doesn't work that way. Once you take these piecemeal parts, the things that you already know how to write as a senior engineer or higher, and you offload those to AI, then you're just vetting it like you would a pull request, a junior engineer. Where you still need to use your brain is how to put the parts together in design. And all you've really gained is the ability to say something that would have said, oh, here's 2 weeks before we can pivot. Here's a day before we can pivot. Right? Because you might generate that class and it might write something that you realize this approach won't work. It did it faster than it would have taken you to reason through the same amount of code. So there's agility gain there. But it's not going to write the whole solution for you in a way that you could then turn around and be responsible for. Which I think is the part that a lot of these startups are missing when they're saying, oh, you can generate a whole solution and deploy it. That's great. Whatever it wrote, if you don't understand it and you don't have anybody audit it for what it's doing, let's say it starts leaking passwords and credit cards and whatnot into the web console. Guess what? You can't point to the tool and say the tool made me do it. That's on you. So don't put AI as the only thing between you and delivery, because we're not there yet. We're nowhere near there yet. Oh, that kind of sums up what I wanted to cover today. If you found any of this helpful, leave a comment. Let me know if you want more of this. I'll probably deep dive into some more niche topics just because I feel like it. We'll see where we get to. But otherwise, thanks for watching.